all. I hope you all enjoyed your lunch. The first session, or the first talk in this session will be from Dwayne Wessels, and he will talk about message digests in DNS zones.
Thanks, Ralph. Are we good? Okay. So welcome back, everyone. As Ralph said, I got to talk about message digest for DNS zones. This is some IETF work that I've been working on with a few co-authors, Pete Barber, Matt Weinberg, Wes Hardiker, and Warren Kamari. So the motivation behind this is to have, so this is my outline. I'm getting ahead of myself. So I'll talk about the motivation. I'll talk about how this proposed algorithm works. I have an implementation of it, so I'll give some experiences with that implementation. And lastly, I'll finish up talking about how to make this work with large dynamic zones. Okay, so motivation. Given a DNS zone file, how can you know or tell if it's authentic? We feel that it should be possible to verify the zone's authenticity independent from how it was received or when it was received or from where it was received. It'd be great if you could do this as a self-contained zone file, so embedded in the zone itself, utilizing DNSSEC for strong security. And possibly this is something that you might want to do before you loaded such a zone into a name server. So to be clear, what we mean by authentic is that the data is as published by the zone owner or operator. It's fully complete. There has been no deletions or additions or modifications to the records in the zone. So historically, the distribution of zone data was pretty simple. You had a master server and some number of secondary servers, and you could do zone transfers secured with TSIG, or maybe even not secured with TSIG, maybe just secured with address ACLs or something like that. The reality today is that it's much more complex. We have multiple third-party DNS providers. A given zone may have many different organizations providing service for its zones. We have much wider distribution due to Anycast and other technologies. We have an RFC called RFC 7706 running a root server on loopback, and if you participate in ICANN circles, you may have heard of something called hyperlocal root, which is kind of the same idea, running copies of the root zone on lots of different name servers. And there are some other potential uses for something like this, including RPZ. So RPZ is policy information encoded as a zone file, right? The CZDS is zone data that's available from ICANN. You can download it via their website and so on. And another similar thing is catalog zones, which is sort of some emerging stuff within the IETF. I'm not sure what its current status is, however. So you might wonder, is this something new? Or is this something old? And in fact, something like this was proposed many, many years ago, as many as 20 years ago in RFC 2065, talked about a transfer AXFR signature. And this is really very similar to that. RFC 2535, which was the follow-on to that first one, later dropped the idea of the zone transfer sig from that RFC. But the idea is I think is still valid. In the RFC 2065, this idea got, I don't know, maybe half a page of attention. It was not I would say not fully specified. It only applied to zone transfers, and I believe it only applied to signed RR sets. On the mailing list, we had some discussion, and Oliver helpfully reminded us that this was eventually dropped because they couldn't, they didn't know how to solve the problem of doing it for large dynamic zones. So we'll talk about that later. So I want to really make the point that this idea of the zone digest is about providing what I call data security over channel security. There was a lot of discussion on the mailing list about, why not just use HTTPS and so on. What we're proposing is to secure the data versus to secure the data at rest versus securing data in transit. If you have channel security, you're placing a lot of trust in a server or a service provider. But if you have data security, you're placing your trust in the data publisher. With channel security, your security is ephemeral. It sort of goes away once the channel goes away. With data security, that trust persists. Another question that comes up a lot in regard to this idea is, doesn't DNSSEC already solve this? So certainly DNSSEC is designed to protect clients or caches from false data. But DNSSEC doesn't really protect consumers of zone files. In theory, consumers of zone files could validate all of the DNS signatures in a zone and the NSEC chain and all that. That does not happen today. There's no implementation of that. Another characteristic is that delegation records are unsigned. And down in the lower corner there's some stats from the root zone, which has, as of that date, it has nearly 11,000 RR sets, 1,400 of which are signed, and 9,000 of which were not signed. Additionally, there's other uses of DNS data and DNS zone files that, other than like, are used in query response, where you would typically do validation. So I already talked about RPZ and other control plane uses of DNS. SOA queries between masters and slaves are generally not validated. And there may be other uses that we haven't yet thought of for this. So if you want to do this, why wouldn't you just use one of these other existing technologies, such as those listed here? So PGP certainly is designed to do this. SMIME similarly is designed to secure data. The problem with those is that you either have to make a choice to have detached signatures, in which case there's really not a strong enough binding between the signature and the data that it protects, or you have to sort of modify the data that you're signing into some other kind of object, in which case, for DNS, it's no longer a zone file. It's an SMIME object or a PGP signed message, something like that. You could use one of these channel security things like TLS, TSIG, SIG0, but as I already said, those are ephemeral. They only protect the channel and not the data. And we've already talked about DNSSEC. You could add DNSSEC signatures over unsigned data. That's something that the design of DNSSEC did not feel was necessary, but in theory we could add that. That would, in some cases, make zones bigger, but you could do that. Another idea that's been thrown out is to, say, have a hash or a digest for each RR set. And again, this would work, but in my opinion, it's not a great solution. It would add a lot more records and a lot more data to a zone file. It would essentially double the size of any zone, or quadruple. So I'll talk a little bit about how this proposed message digest for DNS works. There's a new proposed RR type, which we call Zone MD, Zone Message Digest. This record would exist at the apex of the zone, and it has 4 fields. There's a serial number field. In this case, the serial number matches the SOA serial number so that you can correlate those two and know which version of the zone the digest was generated from. There's a digest type field, which is very much like the DS record digest type. There's a field which, in the latest version of the draft, is marked as reserved, and I'll talk about that more later. And then there's the digest itself. So one sort of open question currently in our draft is, to what extent should, for example, the Zone MD digest type track the DS record digest type? The DS record digest type has an IANA registry, and those digests, those algorithms have statuses with respect to whether they are should be used or should not be used. Initially, my feeling was that in order to keep things simple, this record should just exactly track the DS digest type, but there was some discussion on the list that maybe some of those digests are not appropriate for this use, and so in the latest draft that's out, it says the digest type values are the same, so 1, 2, 3, 4, but only certain of those digest values are allowed to be used for the ZoneMD record. So here's the process for, say, calculating a zone digest. First thing is to add a placeholder record into the zone. Thank you. This is, the reason for this is that you want some of those fields to be protected by the digest itself, so you sort of add it early. The next important step is to have a sorting algorithm for the zone. And the sorting algorithm for this is almost exactly the same as the sorting for assigning with DNSSEC. One difference is that DNSSEC didn't specify how to sort RR sets having the same owner name, so very simply we just adopt or sorting based on the numeric record type. If the zone is to be signed, this would be the time to do it. You would sign the whole zone, and then you would calculate a digest over the zone as described here. So the digest is calculated over all the records in the zone. You would exclude any extra SOA records. Sometimes zones have an SOA record at the start and the end. You include the placeholder ZoneMD record, but you exclude the RR-SIG over the ZoneMD because that's done later. Got a simple diagram here which shows how this works. I'm going to go through it kind of quickly. This is a very, very small zone. You would add this placeholder record. You would make sure that placeholder record is sorted correctly in the zone. Then you would calculate this hash, and then after the hash is calculated, then you update the hash value in the zone itself. Verifying the zone is pretty straightforward. Some steps described here say if the zone is signed with DNSSEC, then you can know if the ZoneMD record should be present or not. You can obviously validate that the record. You should check that the SOA serial matches the ZoneMD serial and so on, and then you calculate the digest and compare the digests. So as I said, we have an implementation, and I've got some benchmarks and experience with that. This implementation is based on LDNS, and it supports the things listed here. It reads the zone file, it adds the placeholder, computes the digest and updates it, recomputes the DNSSEC signature over the ZoneMD record, and can verify the digest from the input file. Shane Kerr at the last IETF hackathon made his own independent implementation, and thanks to him doing that, exposed a bug in my own, a byte order bug. So we have 2 interoperable implementations at this time, which is nice. So I have 2 benchmark graphs. These benchmarks are run over all of the TLDs, and you can see it's this nice line. Both of these axes are logarithmic, however. On the top right there, the net zone is marked. So it took a few minutes to calculate a digest for the net zone. Would have liked to include COM here, but couldn't load the whole COM zone with LDNS on the machine that I had access to, so net is as high as we can go. In the middle there, you can see the root zone. I think it's about 90 milliseconds to calculate the digest for the root zone. And this is the times for validation, so it's essentially the same operation, so they're very similar. All right, so one of the things that, again, came up a lot on the mailing list is how do you handle large dynamic zones? Dynamic zones by themselves aren't particularly a problem, and because if it's a small dynamic zone, that's not a big deal. And again, large zones on their own aren't a particular problem, but if you have the combination of a large dynamic zone, then you're faced with calculating this digest pretty frequently, and we need a better solution than what I've talked about so far. So the idea, and this part is not really in the draft at this point. This is sort of more future work. although this is in the implementation. But the idea is to partition the namespace using a non-binary Merkle tree. Note, not a blockchain, just a Merkle tree. The field that I talked about before, which is reserved, would become a depth field, which defines the depth of your Merkle tree. And then the digest, you do digests over the leaf nodes, and digests at non-leaf nodes are just sort of work their way up the tree. So I've got a little diagram that shows this. This is a hash tree of, I think it looks like 5 wide by 5 deep, I think. And if you can divide the zone up in this way, using some kind of function, as there's a little prototype down there that says get branch for any name and depth and tells you which branch you're at, then this is pretty straightforward. I've got a bunch of graphs that show how using a Merkle tree of different depth and width changes the time to calculate the digest. So this is from a small TLD. The purple line at the top shows depth 0, so that's no Merkle tree really, that's just a straightforward hashing. And then as you add more depth to the tree, for the most part, the calculation time gets lower and lower. Although in this case, there's a point of diminishing returns, and the sort of orange line there is at depth 9, and things are a little bit higher. This is for a medium-sized TLD with something like 1.5 million records. Looks similar. This is for the .NET zone, and this is for the root zone. So this is just the time to calculate the hash sort of from scratch, from nothing. It's interesting to see that the calculation time improves just by adding this Merkle tree. But the real benefit is in doing the updates. So if you have this sort of structure in place, doing an update is significantly faster because you're only rehashing a very, very small subset of the records. And that's what these graphs are designed to show. So for this small TLD, you can see, and again here the y-axis now is logarithmic, so there's a very significant benefit going from, say, half a second to do an update with no depth to something like 1 millisecond at depth 5. And most of the zones that I did work out this way. So for a medium-sized TLD, again, with a depth of 5 or 9, your updates are about 1 millisecond. This is for .NET. Again, 1 millisecond at depth 9, maybe like 50 milliseconds for depth 5. For the root, this is for the root zone. So that's the proposal. This has been published as Draft Wessel's DNS Zone Digest 03, and that version of the draft does not describe the part that I just finished up with about the Merkle trees and whatnot. So one of the questions I have for you, and especially anyone who would be faced with implementing this, is the complexity of doing some of that Merkle tree stuff worth it? Is it worth the performance gains? Is it worth the hassle? There's an implementation listed there. Please, give it a try if you're so inclined. And happy to take questions. How much time do we have for questions? 10 minutes. Oh, 10 minutes. Okay.
Ray Bellis, ISC. It wasn't clear from the slides, and it's a while since I read an early version of the draft, but is the ZoneMD signature also calculated over the RR SIGs that are in the RRs, over the RRs in the zone?
So the hash is over all of the data in the zone. It's over the wire format encoding of all the records.
Okay. Just wonder what the utility is of necessarily hashing over the RR SIGs themselves. given that they're essentially just signatures over the individual RR sets.
I don't understand. You're wondering...
Well, it's just, yeah, could you actually improve the efficiency by not bothering to calculate the digest over the RR SIGs themselves and just actually do over the R data of the non-RR SIG records?
I don't know. You probably could gain some efficiency, but one of the goals is to have some hash over the data that's not already signed.
Of course. Yeah. But the... Yeah.
You're thinking efficiency in terms like I'm there calculating the signature, why not just hash it at that time? Or...
No, just if you're just iterating through the zone, accumulating data you're going to actually calculate the hash over. It's just not clear to me that you actually gain anything from taking the hash over the RR SIG data that you're already calculating as you sign the zone. So you're just working on less data.
So I'm not proposing hashing only signed data. I'm proposing hashing the whole zone. The older proposal was, very old RFC was hashing over only the signed data.
Hey, it's Joe Abley. So this is a comment for Ray. The zone might not be signed properly. It might not have the full complement of RR SIGs. It might be useful to be able to record that and know that two different versions of the zone are different. So I think including the RR SIGs makes sense.
Yeah, and Warren Kumari also kind of responding to Ray. So sort of one of the obvious use cases for this is the sort of local root thing where you just load the whole root zone in. And it would be nice to be able to actually walk through that and know that you've got all of the stuff before you start serving it. And if you don't, don't bother sticking it in your stuff. Yes, you could walk through and then take everything where you have an RR SIG and go and actually check to see whether it all works out. But that sounds like a lot of back and forth in circles. And
yeah, I mean, the bind implementation of the local root stuff verifies the RR SIGs when the zone's loaded anyway. So there isn't necessarily anything to be gained in that scenario from actually checking the RR SIGs because we already checked them.
well, maybe you wouldn't have to.
Yeah, okay. Yeah.
Thanks, Shane.
Hi, this is Shane Kerr, the other implementer of the earlier draft. Yeah, so I had a brief talk with Dwayne about this, and he was surprised that there wasn't more interest in this. I also am, because I think it seems like from an operator point of view, once this is implemented, it's a straightforward additional safety measure, right? And if you're in a business of secondarying zones, it can prevent you from accepting invalid data from your upstreams. If you just want to get copies of zones, like from the root zone, it also provides an out-of-band way to check it. So I think Dwayne went into great detail about how it works, but really from an operator point of view, it's basically pretty simple. It's like run the check, does it work? Or add the check, and then you're done. So I think it's great. I think we should move forward with trying to get it standardized and hopefully try to convince DNS implementers to adopt it. That's going to be the tricky part. I think they all hate it and just view it as more work, but that's...
Right, and one thing I may have glossed over a little bit is, again, based on feedback from the ITF, this is now being put forward as an experimental draft rather than standard, so a little bit lower bar, I guess, to get it to get a code type. So.
I mean, so many useful things in DNS are not implemented. They don't have any standards at all, and
Yeah.
a lot of standard stuff isn't implemented anywhere. So yeah I don't know.
Petr Špaček, CZNIC, DNS implementer, I should say. This proposal makes me sad, and I think that Camel will be sad as well, but the Merkle tree makes me cry. So please, I would suggest in the first version, if you really insist that it's necessary, I would go for the first version without the Merkle tree and even without the result field, and then the second version can be, different RR type. It can be zone MD version V2 or something with Merkle tree or whatever. And yeah,
okay.
I'm not happy from the complexity in the implementation, but maybe I can see the advantage from the operator's point of view, but it's not as easy when we are talking about DNS server which is making million queries per second and dynamic updates. Then it's like, of course, you don't want to walk through all the zone data to,
Right.
accept one dynamic update. But yeah, we can talk about it afterwards.
Okay. Thank you.
James Raftery, AWS. This complexity of this may indeed be a camel killer, but as somebody who has 3 times, I think, consumed bad data through IX from an upstream who broke their deltas, being able to scan my fleet and determine that I have the same version of the same data with one query instead of having to download every copy of every zone and diff them all. I had to write a tool to do this.
Yeah.
And so if you put that in there, I would love you forever. Thank you.
Okay, thanks.
Matt Poundset, and this is probably, the original use case anyway, but yeah, this seems fantastically useful for consuming zones from CZDS and things like that, just to know for a fact that you've got the complete zone. Yeah, it seems incredibly useful. Thanks.
Okay.
Dr. Špaček, once again. If you are an operator and you are interested in this, please come talk to me, because I want to hear the use cases, right? It's a very different thing to calculate the digest after every single update, and it's second thing to provide, for example, a command which can, request the server to calculate the digest from its data which are in memory right now and tell you the digest so you can compare it with the other servers and so on, which is totally different use case, and I would like to hear from you what you think is useful.
So I guess Warren Kamari responding to Peter. I think that, one of the original discussions on this was simply for the root, in which case you don't have to deal with dynamic stuff, you publish it once. And a lot of the discussions that I've heard on it are or speaking to operators, people who've been supporting it, is a lot more of we'd like to just have a point in time thing. Having it done after a very fast zone with lots of dynamic updates, you could either just choose not to do it for that zone if it's painful, or you could just do it at a point in time. Please, sync the file and calculate.
Hi, Peter van Dijk, Power DNS. I'd like to mirror what Peter said. If any operators could tell us about more use cases, we'd be interested. But also after some discussion, we realized that this is simpler than 6.0 and more widely applicable. So we kind of like it.
Okay, cool.
Matthijs making Dyn. I think I'm not yet clear on why this has to be in-band. So why does this have to be in the DNS, and why not just a hash over the zone?
And where would you have that hash be?
Okay. Yeah, because the reason I asked this question is you're going through all kinds of hoops to calculate the digest and validate the digest and ordering and yeah, that.
So to me, the ordering is not a big deal because you already have to order. I see this digest as being generated alongside DNSSEC signatures, right? So you already have to order it for DNSSEC. It's essentially the same ordering, right. So it's not new. This crazy depth of Merkle tree stuff that I talked about, that would require a new data structure in your name server, which that's where the complexity is, and that's not in the current internet draft.
Right. Okay.
But some people seem to have wanted that, so that's why I kind of talked about it. But I think to me it makes a lot of sense to put it in the zone itself. I don't see the downside to that, I guess.
Yeah, let me think about it before I say more words. The other thing, I think if there's use case for it, then we should do it, and we should not try to cover all cases. Maybe it's a good way to come up with a different solution for highly dynamic large zones.
Yeah.
Or maybe a second version that deals for that case. So.
Okay, thanks.
So my motivation is kind of in the consumer space. I expect to consume these products. Lots of things that I do operationally running machines involves downloading things that I am never plausibly going to examine in detail to understand their correctness. And you apply different models of trust. Should I believe this? Yeah, the publisher's put a hash checksum on it and is inviting you to go and check it to see if it's valid. This patch file that you're going to apply, binary or text. this digest over a set of changes from state A to state B. You're being told, we're being trained in the positive sense, you have an option to check here. I'm giving you an assertion, this is what you should see. Go check it, see if it's what you see. It doesn't mean you don't have risks in consuming complex things, but it's a step up from just blindly running the SHA file that you're given an email that you're told will patch your kernel. So for me, it feels like a no-brainer. Why wouldn't you have this? So inside the system, heaps of people in the DNS are kind of, why are we doing this? We don't have to do this because we have this mechanism, that mechanism, 16 other mechanisms, 21 ways we decided to do this, all these problems, canonicalizing. And I'm thinking, wow, this is weird, because in any other domain, having someone say, I'm prepared to invent a framework for you to get improved trust in a specific blob of binary or ASCII data that you are going to incorporate into a functioning system of yours to give you an opportunity to check that it is exactly what I meant to give you, that's very good. So we have this weird thing in DNS about split roles. Who is the actual authority of a zone? Who is the person mechanistically making the state of the zone? And there are moments, I think, I'd like to know that maybe the authority can say this is what you should see. And that doesn't necessarily fit well with the mechanisms behind how the maker makes what you should see. But canonicalize the file, create the digest state, and then have someone say, this is absolutely what I want. You can do that. You can start to add things into this. So I really like this. I like it a lot from a consumer side.
Yeah, thank you. I agree.
Joe Abley, I just thought I thought of something when this was being discussed on the list. A lot of people are trying to suggest that this is unnecessary because they can have channel security of some kind. TSIG with a well-known key or something else.
Yeah.
And I think that kind of misses the point. I think your earlier slide, when you talked about the DNS used to be simple, you had a master and a couple of slaves. And it's not only more complicated than that in terms of the graph that you use for zone transfers, but you don't have to use zone transfers.
Right.
You can do all kinds of innovative stuff. You can do peer-to-peer protocols and flood updates out sort of opportunistically through all kinds of third parties. And there's no opportunity for channel security through that in general.
Right.
So I like this. I think it's good. I think just like you can trust a signed RSIG as a unit because you've got a signature you can verify, this gives you another unit, a bigger unit that you can trust, which otherwise you don't have. So I think it's useful.
Yeah, thank you. Okay. Thanks.
So the next two talks are about the DNS Flag Day, with the first one being from Sebastian Castro.
Hello again. So this is a short presentation. The opening act of the Peter Spacek presentation about the DNS Flag Day. Probably you see in the program the presentation is called A Tale of Two CCTLDs, turned into a tale of 5 CCTLDs with the cooperation of Peter. So let's dig into the results. So this is a joint work between Hugo from .cl and myself from .nz with contribution, high level of contribution from Peter Spacek from CSATNIC. So what is DNS? Well, you're the wrong audience to go and explain what DNS. So it's a mechanism to support new DNS options, to make it more awesome and to go and extend it and make it more things. So how it's currently used? The list is not intended to be extensive, but we have NSID, we have DNSSEC, so we cannot have DNSSEC without eDNS. We have the client subnet, keep alive, cookies, and many other improvements to the protocol that rely on eDNS. So what's the problem that we be trying to be solved and we're trying to measure here is from the authoritative point of view. There are servers that don't block responses. They have all implementations of the software. They don't know how to go and manage new options. There are bad implementations. So we saw the presentation yesterday from Bert about how difficult it is to go and implement DNS. We also have network devices in between doing funky stuff with DNS packets because they think they understand DNS. or they are unaware, or they don't care, etc. So it's a messy place. So we are talking once again about the messy place that's the internet. And if you have a feeling of deja vu with this presentation, it's like we have the same talk where the root zone was being signed, and the large packets, and fragmentation, and what is going to happen? Everything is going to break. Let's run to the hills. Well, we're still here. We roll over the key was rolled over yesterday, and nothing happened. So this is the next step of the DNS maintenance year. So we're trying to measure this. So the DNS flag day. 1st of February 2019, put it on your calendars. I'll give you a few seconds if you want. The DNS flag day. So the DNS implementations we have in the room, Power DNS, Unbound, Bind, and Not will be releasing new versions that will remove the workarounds around eDNS. So if you have a non-compliant name server, those resolvers of new version talking to that authoritative name server will fail. And there's a possibility of the domains will break. So we wanted to know how many domains could be affected, but this presentation is focused on the name servers. Peter's presentation is focused on the domain names. So it's a coordinated effort to measure this at .cl, .cz, .sc, .nu, and .nz. And also we have, thanks to ISC, we have the collections around the root zone, so we have a comparative point of view. And again, thanks for Peter for the feedback, for getting the data, for sending us data, and writing the tools, so part of the tools. So in order to do this measurement, there are two components. One is the DNS compliance testing from ISC. Thank you, ISC. Thank you, Mark. And we are only using the subset of eDNS compliance checks against name servers. And Nick wrote a tool to go and pick a large zone and only test what is needed to be tested. So when you have one name server hosting 30,000 domains, you don't need to go and test that 30,000 times, just once, or a number of times. So you can pre-process a TLD zone and get the minimal set of name servers you need to go and test. So Peter wrote that tool in Python, so you can go and run it, pick up your zone, run it, and have an experiment. So we test multiple times a name server in order to go and remove transient errors. There is a hierarchy on the eDNS tests because different flags are added to the queries. So certain tests are far more complex than others. So you can see that there is a split. You can go and go for eDNS 0 or eDNS 1, and then if you go for the path of eDNS 1, you can start adding the EDO opt or not, and you have different tests. So there are 9 tests there, and we're focused our results on, we're reporting results on 4 of the tests, but we have all the data for the rest. So general statistics, we're comparing completely different zones. So the CZ, .cz zone is like 1.3 million domain names. The .cl zone is like 450,000. The .nz zone is 700,000 domain names, but we're testing name servers. And I was surprised to see that, and we have in that dark brown the root zone just as a point of reference. I was surprised to see that even as the CZ zone is double of the .nz zone, the number of unique name servers or IPv4 addresses is not double. It's barely, it's actually the .nz zone has more unique addresses than .cz, so there's a clustering there of addresses. What I need you to keep in mind from this is that servers are only IPv4, not surprising. There are servers that are dual stack, and there are servers that IPv6 only, because we will talk about differences in IPv4 and IPv6. And yes, it is still a topic. So the base DNS test is sending an SOA query to the name server, and you can see the root zone has nearly, it's 99.8% passing that test. And the rest of the domains are over 95 with a few lame delegations. So the no SOA, and the no AA responses are lame delegations. So nothing interesting to see there, but that's our starting point. That works. It's like, yeah, the name servers respond. But we start adding EDNS, and we start getting some interesting results. So the root zone, again, is 99.8. Not surprising without the IANA test. And you start seeing name servers that you send the query with EDNS 0, and the response doesn't include the OPT record. Violation of the protocol. And the other most relevant error we see is you send a query for EDNS 0, just a plain query, and you get the NSID in the response. It's like, I send you this. It's like, no, I'm feeling generous today, so I'm going to throw you NSID in the response. But when we move from testing from EDNS 0 to EDNS 1, oh wow, this gets really, really interesting. So the root zone is, again, 99.5% passing this test. But you start seeing the CCTLDs and the detection of the error of EDNS 1. So EDNS 1 has not been defined, so the correct answer is an R code bad verse. But you start saying, okay, no, I'm sending you the SOA, not a problem, it's all good. I won't send you the OPT record. I will say something else. So you start seeing all kind of rubbish already. The DO test, essential for DNSSEC, and .cl and .nz are assigned domains, is that CL and NZ, we have 20% of the name servers that don't send the DO bit on the response. So we need to do something about it. The rest are looking all good. And the OPT list is kind of, I call it the measure of how updated the name server versions are out there. And you can start seeing so NSID is the oldest option with the highest level of adoption, and then you start seeing subnet with the second oldest, and then expiry is the third oldest, and the end. So this is kind of the tale of how frequent and how modern the name server versions are out there. So are IPv4 and IPv6 different on this? And we can go and test how different they are. So what you're seeing here is the difference between IPv4 addresses against IPv6 addresses that pass the test. So if the bar goes to the right, that means IPv4 tests pass more than IPv6 of the same test on IPv6. So the DNS and the EDNS test, they are passed more in IPv6 than on IPv4. That was surprising. Okay. The EDNS1 and the list test pass far more in IPv4 than in IPv6. I suppose there are some filters there that don't understand that kind of packet, so they're too new. We've been doing this collection for a time, so we started around May. We have data for all the CCTLDs between May and July. That's the first data point, and the second data point is from October. And .cz started their communication campaign with the domain holders, and you can see the difference. So they have an improvement of roughly like 2% around the test for EDNS opt and the DO test. The rest, we haven't done anything. I don't know. I cannot talk for the Swedish on this, but we haven't started, and .cl kind of started, so we haven't seen a lot of change. So to correct the errors, you need to have a reasonably modern implementation of DNS software that uses the standard and pay attention to your firewalls. You can retest. The DNS flagday.net site has a tool to test one domain name. And we're planning to go and keep the collection, do a communication campaign to domain name holders, and we encourage other namespace operators to go and check their domains and get some similar metrics. If you're interested in the software to do the analysis, we'll have it available on GitHub, so you can go the pretty graphs. And that's it, because I have to go and finish. we have any questions, or we can make Peter present first, and then we have two, Jeremy.
Jaromir at CZNIC, maybe it's not a question for you. Yes, so the question about measurements, first time we talked about that with Peter, I asked him why this is not another measurement in the zone master. And because a lot of registries is using zone master for a measurement check. So I think there was an attempt to integrate it, but I don't know the state. So I don't know if you have evaluated somehow with the authors of the zone master if this can be somehow integrated.
Do you want to answer that, Ulrich, or no? No, this is a different thing. Okay, yeah, so probably we need to go and take that offline and okay. Ask the guys from AFNIC about adding that there.
For testing handling of unknown EDNS option codes, can you clarify whether you were testing a static unassigned code like 100, like a lot of implementations do, or a randomized unassigned code?
It's a fixed number, it's 100, yeah.
Yeah, well, so just one authoritative we've encountered is doing deep packet inspection has a whitelist of EDNS option codes, and if they were to add 100 to that, they would pass, but they would fail. So yeah. Can you consider randomizing within the set of unassigned codes?
Sounds like a good improvement, yeah. Peter.
Peter Koch-Dienig. When you measured the name servers, did you actually address or use all the addresses that were provided?
Yes.
Did you find any differences? You mentioned V4 versus V6, but did you find any differences between differing V4 addresses, like on-path interception?
For the same name server? For
the same name server.
I know Hugo found a specific case of from one provider that IPv4 worked one way and IPv6, so the same name server worked a different way. But we haven't looked up extensively on that.
No, but same address family and different addresses, you didn't look into that? That might be interesting, if you didn't do that already.
Probably I did, and I didn't find anything interesting.
Okay.
Yeah. So, so I did the analysis for dual stack name servers. So name servers that have both IPv4 and IPv6 address, and they behave the same.
Okay, but okay, offline.
Peter? Yeah, you definitely do see differences between name servers for the same zone. You definitely see different implementations behind heterogeneous anycast clouds and stuff like that. If you look on my site, you'll see history back 5 years or so of measurements along this too. So.
Okay, thanks.
Okay.
This is Ulrich from IIS Internet Stiftelse. Okay, I got to
new brand.
I got to work on that. Yeah. So we received the measurements actually from Peter, and I looked at it. So the largest part, the first one was DNS pod, China shops. We would be really happy if they go offline, so we don't do anything with them. Second was China shops too. Third is actually Nestle. Of all the companies in the world, they are the one that were going to stop working, so I don't know. And I tried to contact a lot of more on the list, but we got very little response, I have to say.
Yeah.
So
it requires some work to go and start banging the drum and make them change. Yeah. Yeah.
So next up is Petr Spacek.
Hello. Thank you, Sebastian, for his previous talk, which was focused on the name servers. And now, in our next talk, we will try to summarize this and see what's the impact on the domain names. So let me see if I can operate. Okay, so prepare for the impact. It's going to be interesting and wild ride. So the, let's say, research question is what happens in practice if the resolvers will not retry after a query timeout, or will retry but will not disable EDNS 0. So let's see. as you have seen, there is plenty of technical details you can measure, but it's not that easy to digest the technical data to final result. So the problem is that one domain name or one delegation, if you want, can have multiple NS names, and every single NS name can have multiple IP addresses, and then some of these IP addresses might not be even authoritative, or some of the NS names might not have an IP address associated with them, and so on. So there is a lot of garbage to go through. In this measurement, we were basically categorizing domain names to 4 different categories. The best one is called OK, which means all tests for eDNS compliance passed. Congratulations, and thank you for all of the operators which operate these beautiful servers. Then the second category is so-called compatible, which is, well, the best term I was able to come with. It means compatible with the flag day. It doesn't mean like compliant. It means that the domain name will not break immediately, but it will break on another flag day in future, let's say. Then we have the high latency category, which means that there are some serious problems which can be, for example, that some of the name servers or IP addresses of name servers are not authoritative. So basically the resolver will go to randomly selected IP address, will get refused or some other answer back, determine that, okay, this was the wrong IP address and will retry. Or it might mean that some of the NS names cannot be resolved to an IP address. So again, the resolver will have to do more work to get to something which will work. And the last category is the dead, which means that there is no functional IP address for the particular domain name. It's important to note that there are 2 different ways how to look at high latency and the dead categories, right? Because definition of dead is different now in 2018 and will be different after the flag day, because after the flag day, the resolvers will not disable eDNS 0. So the domains which are, let's say, high latency nowadays, because they don't reply to queries with eDNS 0, will effectively, or nowadays, these domains force the retry, right? Because the resolver asks, it timeouts, then the resolver asks probably again, it timeouts again, then the resolver will execute its workaround code and disable eDNS 0, retry, and get the answer. That's the state in 2018, and that's what's causing problems. Next year, we will remove this code for workaround, which means that the resolver will ask with eDNS 0, it will timeout, and it will ask with eDNS 0 again, and if it consistently timeouts after eDNS 0 query, it will be just dead. That's it. Okay. Its evaluation of this is quite involved, so I strongly recommend you to go to the website. It has a README which describes all the methodology, so if you want to get all the details, I encourage you to go to the web. The same link leads to the repo which contains code which you can download and use to scan your zone files. So if you're a registry and want to see how your TLD is standing, I encourage you, again, download the code, run it, you will get the results. Okay. I will try to summarize the methodology so we all are on the same page when it comes to the evaluation, so bear with me. First is to basically create a mapping from domain name to set of IP addresses, which is kind of obvious. That's what the resolver does. Then, of course, there are some garbage domains or IP addresses which are not authoritative for the domain name in question. So we need to set this aside because it would be, the noise in the data. Then next step is to test the IP addresses using the ISC gen report tool, which is basically the same tool which was used for the previous presentation. So the underlying test is the same. Of course, it might happen that there will be some random network packet loss, so we repeat the test 5 times just for the good measure and take the majority of the results. Finally, when we have these like bunch of technical results, we need to evaluate them. So first, if all the tests passed, everything is okay, it's super easy, the domain is okay, congratulations. If it's not completely okay, then the question is, are there some timeouts? If there are no timeouts, it's easy, the domain is compatible, which means that it will not break after the flag day. It's not standards compliant, but in a way which will not break. So yeah, I'm not happy about these domains, but okay, at least something. Then it gets more complicated, because now we need to evaluate what's the state today and the change after February 2019. So so-called permissive mode is like today. And if the plain DNS works, and by plain DNS I mean eDNS without any extensions, if it works, okay, the domain is high latency because it forces basically the resolver to go through the workaround cycle to disable eDNS, and of course the users will feel it. If we are evaluating the state after the flag day, it's different, because if only plain DNS works, but it timeouts with eDNS 0, it effectively means that the domain will be dead, or IP address. And then once we evaluated the results for every single IP address, we combine the results for the set for every single domain name, and that's the final result for domain. There is a bunch of limitations. First was already mentioned, that's the unicast, right? Because we were testing mostly from one place in the network, so if the Anycast network is using wildly different implementations, well, we will not see that. Of course, the DNS tree can be quite high or deep if you want. So we were focusing basically on the TLD level. So if there is broken domain a.b.c.d.example.com, we will not find out. Next limitation is that the assumption is that one IP address or name server behind an IP address is kind of consistent in a sense that it doesn't disable eDNS or some options depending on the domain name you ask. So if the name server is authoritative for example.com and example.net, we assume that if it supports eDNS for example.net, it will support eDNS for example.com as well. That's kind of optimizations, as was explained in the previous talk. And of course, the most important limitation is that not all domains are equal. If Facebook, Google, and YouTube works, half of the internet population will not even notice the flag day, no matter what happens to the rest. Okay, finally, some results. Root zone. We were scanning the root zone, and surprisingly, it turns out that one top-level domain will break, which was like, ooh, what we are going to do? And then I found out that, well, it's North Korea, which is kind of complicated to reach. So I've attempted to contact them using the contacts from IANA registry for TLDs, but of course nobody replied. So if anyone has a contact or at least can write Korean, I will be happy to translate the message and send it again or something. Okay, so next TLD. Or let's move to TLD level. Scan at CZ TLD shows that the breakage is about 0.16% of domains. You can see in this table two columns. One is state today, and the second is state next year. And basically, the change is how many domains will move from the high latency to the dead category. And the change here is 0.16%, which is visualized in this. Basically, the changes from red to the black. So, something will happen, but nothing important. Okay. In the Swedish domain, the breakage seems to be about 0.27%. And as was mentioned, it's very localized to basically limited number of hosters. New Zealand domain is a little bit different again. Now we are at 0.55%, so about half of the percent of domains might break because of the flag day. And we are still going up. If you look at the Chile, the breakage is about 0.93%, so a little bit less than 1%. Finally, it's visible even on the graphs in here. Okay, NU, it's about 3% breakage, but that needs to be said that it's much smaller domain, so it's again localized to a couple of hosters. And the biggest domain we were scanning is .NET, and the breakage in there is about 3.94%. So that seems significant, right? After scanning the .NET, we have taken about 150 top-level domains from CZDS, provided by ICANN. Thank you for that. And we ran scans over these TLDs and combined all the results together. So it's like approximately 23 million domains which were scanned. And the grand total is about 5.5% breakage, which seems horrible, right? We are still going to bigger and bigger numbers. What do we do? This is summary which looks at the biggest TLDs we were scanning, and it's ordered by the breakage. And you can see that some of the TLDs are super broken, or maybe not super. Wait for the next slide. This is the list of the TLDs we scanned, sorted by the breakage, and that's like, well, I don't understand what they are doing. Okay, so now it seems pretty horrible. We shouldn't do it. Stop it. Go away. Never try this again. Is that right? Well, it's really important to analyze the data further, right? Because not all domains are equal and not all DNS hosters are equal. So it turns out that vast majority of the breakage is localized to a very small number of providers. In particular, the Hi China, which is Alibaba DNS, which is over here as well, and DNSBot, which has two main domains, are responsible for 2/3 of total breakage worldwide, according to our measurements. There is some problem with contacting them and so on, but well. And the other providers which are responsible for breakage are in this table, and together these like 8 providers are responsible for 85% of breakage worldwide. So, you know, if we can get some communication going, it might be feasible to actually fix that. So, as I said, it's time to prepare, because this guy is not going to save you. And to conclude, thank you for your time, and if you happen to have contact to any of these, I will be really glad if you can approach me and if we can get the communication going, because often it's really about the communication and nothing else. It needs to be said that the meta register and register servers are aware of the problem already and working on it, so we need a contact for the remaining 6. Thank you, and please, your questions.
Short question, Marco Davids, SIDN. What is an acceptable error rate for the go, no-go decision?
well, there is no such decision, right? It depends on the domains which are broken or not, because, so,
but
there
is a date set at the moment. What can I expect?
Yeah, that's the point. We are going ahead because it seems that it doesn't break anything really important, like Google, Facebook, and YouTube. So.
Thanks for the clear answer. I'm glad I asked the question.
Well, the main point is that the DNS resolver developers were bearing the cost of these workarounds for 20 years or more. And next year, it will be 20 years since the eDNS extension RFC was published. So maybe after 20 years, we are fed up with workarounding the broken stuff. And of course, if you have a couple of spare $1 million and you can give like 1 million to each company developing the resolver, maybe we can, postpone it. But of course, there is some space for negotiation.
Do you have any idea on the effect of the domain names inside the domains? Like lots of the breakages that we see and have to do workarounds for are related to a few load balancer products.
Unnamed companies, yeah. They didn't make the list because they are not a DNS provider, right?
Okay, so the damage could be much worse. Or much
Nobody
better.
knows. Well, basically, the tool is available, so I strongly encourage anyone who is interested in this, take the tool, take zone file, run it. It basically is zone file plus one command once your machine is set up. And that's it. It will spit out the table as you have seen on the slides. So it's not hard. If you are a company, for example, big hosting company, it will be really useful to run equivalent of this scan on your infrastructure.
Yeah.
But we don't know because we don't have the data.
We're participating, so we will see what breaks. I know a few companies that will suffer badly that are in here.
Please. Oh, okay. You were first.
Okay, I've got contacts at most of these, so come talk to me afterwards. And,
Perfect.
And also the KP guys, unusual, but John Crane with ICANN. But come talk to me afterwards and I'll...
Perfect. I will try to find you. If I don't approach you, me, please.
Hi, Puneet from Google. I already asked you about .com. You were unable to run the test, but do you expect to see a few more providers show up there if we run the test for .com?
I don't have the data, so it's hard to say, but it seems that once you get to, let's say, international TLD, like .NET or some of the new TLDs, this like proportionate market share of the DNS provider seems to be more or less the same. So I expect that my wild guess would be that the table will be the same.
Okay, thanks.
But again, it's wild guess. I didn't scan .com because I would have to optimize the software and,
Hello, it's Peter van Dijk, Power DNS. First, a question for Puneet. Right now, on the DNS Flag Day site, we have the Quad 9 logo, we have the Quad 1 logo. It's obvious what's missing in between.
Wait for an update.
Thank you. To Oliver, you're asking about domains under the listed domains. Current development versions of both Bind and Power DNS are already DNS Flag Day strict. So we're finding out as we go along. If our users report, we will report.
Thank you for your time.
So next up is Ombre, and he is going to talk about aliasing in DNS.
Hi, this is Andre from ISC. What a great day it is. Well, you know, the aliasing in DNS is a long-standing problem in the DNS community, and hence the reg there. because we are still on the ground and we need to take off this plane to the air. So basically, when I was thinking about this, I found out that, or the way how to approach the whole problem is that this is not just one problem. This is like multiple problems connected together with word alias, and the one use case is the different scripts in case of Chinese or other languages, that they have two different way how to write down the letters, the traditional and simplified, and they're like equivalent. The other place where it could be used, this use case, is the diacritics. For example, in Czech language, all the domains are without diacritics, without all the acute and hooks and other funky stuff over the letters, and this could be mapped into those with those letters that's not in US ASCII could be mapped to those without. But there's also a second use case, and I call it. I have a website somewhere there, and there could be CDN, there could be hoster, whatever. And it's usually that it's like a domain. The whole alias isn't you don't want a DNS alias. You want to say that my website is hosted at this provider. My email is hosted at that provider. I also have a Jabber server there if you still use Jabber. And for the first problem, it's I ran an experiment during the last IETF hackathon. If you haven't been to IETF, and I tried to actually put a CNAME plus DNAME into the parent zone. I tried putting CNAME and DNAME into the apex of the zone, and I tried what will happen. So as an authoritative server, I used bind. It's a master branch with some extra code changes. It was a couple of lines, and I registered zone CNAME at apex.rocks and CNAME plus DNAME.rocks. It's actually operational right now. And as you can see, the CNAME at apex is no-go, because the CNAME masks the apex usually. So if the CNAME gets into the cache, you can't get any result other than CNAME out of the resolver. So basically, it means that we can't really use this solution for the apex. That said, for the parent zone, if you put a CNAME plus DNAME to the parent zone, it kind of works. And by this I mean that for bind, it works okay. For Power DNS, it fails, but because Power DNS doesn't support DNAME at all, and I've been told that Power DNS 4.2 might have some DNAME fixes in the queue, but I haven't been run their version yet. For Unbound, it also works. Also with the QNAME minimization, everything just works. For not resolver, the DNAME is a similar thing. It's sort of broken, but in a funny way, that you get all the answers, but you also get a serve fail. And for the Google public DNS works, VeriSign public DNS works. I don't know what they are running there, but I guess it might be bind. I don't know, or something they run, but it just works. For Quad9, they run Power DNS and Unbound behind, so it suffers the same fate as Power DNS. And that same goes for the Cloudflare Quad1. They run not resolver, so they share the same fate. Years and years ago, I wrote this draft at IETF CNAME plus DNAME, so I refreshed it. It's a different solution than the ANAME or alias, and it doesn't replace it, but it provides sort of quick, mostly working solution, deployable right now. But it also had it also means that the TLDs would have to support this, and that might be the biggest obstacle. There are some optimization that could be done, like returning the new name along with the CNAME, but the code, the new code needed for making the CNAME plus DNAME in the parent zone is very small. It's like, it mostly doesn't require, it requires a change in the authoritative server, but that's it. And the change is very small. If you look at the branch, it's like, I think, 3 lines or something to the bind source code. So that might be like a solution, like immediate solution for people that needs aliases at the parent level. I'm not saying this will save the world or. So do we still need is there still need for the alias? Yes, but what people really need isn't DNS alias, because they don't want, if they redirect their website somewhere, they usually don't want the mail records, the MX, to be redirected to the same place. And usually the CNAME isn't what you think it is. So what we really need, I believe what we really need is a pointer where stuff is located, where stuff might be, in this case, web. So do we already have that? I think so. So for mail, it's called MX. For, I don't know, river zones, it's called PTR. For everything else, it's SRV records. But browsers doesn't use SRV records for some reason. So can we use the SRV? I think so. I think so. So there are some common arguments that are against this. So it's latency. Then we can just change the authoritative and recursive servers. They will add the records required to quickly resolve the name. So if you ask for, SRV, it will automatically add the A and quote A names into that. Or you can just use parallel DNS queries and ask for both. And if you got what you need from the SRV, you just use that. It's not supported everywhere. Well, the alias A name isn't supported everywhere, and it's only supported by the large DNS providers, and this causes a problem with the vendor lock-in. So you can, there are several providers now where you can have a sort of alias thing, and they will resolve it in behind and return the, instead of CNAME, at the apex they will return A and quote A. That has a problem with DNSSEC unless you use online signing. And it also creates a vendor lock-in. So I think that those people implementing the alias at their service are very happy about the vendor lock-in, but we as a community should remove the vendor lock-ins and make it available for users to move from one provider to another, or use multiple providers with existing technology, even the open source DNS servers. And what if you already use the alias A name? And well, you can use both. It's if we talk to the browser people, which we already probably should, because the DOH thing, there should be an extensive dialogue between DNS and browser people. Well, if they add support for SRV records, we can use both. You can use the already existing mechanism for the legacy stuff and the SRV for the new stuff. And the largest problem is the wildcards. So the _HTTP_SRV wildcard cannot be placed into DNS. The wildcard doesn't work this way. There are a couple of possible solutions, but no, you can't have the pony. And well, those solutions are basically either needs some modification to the software that will add a complexity again, like CNAME plus DNAME at wildcard, which feels so wrong on so many levels. But I just added it for completeness. That needs a new code, but it's also like a wildcard at wildcard thing, which doesn't feel correct. You can also use SRV at the target of the CNAME, so put a CNAME at the wildcard. This is similar what to the discussion we had in the day in working group about the wildcards. It's the same problem. But in that case, the SRV prefix is lost, so you lose the ability to put multiple SRVs for different service at the name. Or just don't use wildcards. It's a provisioning problem. So usually when you use wildcards, it's not, well, in most cases, you don't want to use wildcards. It's just like a most easiest way, but it's really a provisioning problem. Or the last easiest way is just keep using the CNAME there. It will not stop working. So you will just not have a SRV record at the wildcard CNAME, but it will still work because the CNAME worked before and it will still keep working. So thank you for listening, and I don't know, I would like to hear your opinion on what we should do as a community, because this is a problem that clearly needs solving, because we have been talking about it for past 10 years or more, and nothing has happened. So, and we really need to do something because the users need it.
Okay, Matthijs Mekking-Dijn. I think this is good because I like that you keep exploring for maybe simpler solutions. If there's something simpler for the alias, or then we should follow that. However, I'm not convinced with the SRV approach. One of the reasons is you specify a protocol basically, and whereas with alias you point everything at that name to things. So you can solve that by doing all the protocols in SRV records and stick them in, and serve the target with, I don't know, 5, 10 SRV records. But yeah, doesn't feel beautiful. I don't know. The other thing is it's not actually what the record format is. It's how you provision our data, so that basically the target is you want something else, right? You want to resolve it from somewhere else. So I think we need to come up with some solution that how that provisioning is working. I like where Tony Finch is going with the ANAME solution, is that we do this in front of the zone generation. So you generate the content, you do the provisioning of the ANAME, you do the signing, and then you have the zone, and that's it. So, but that algorithm of how you provision that target, that needs to be defined, I think.
Sure. Well, I just wanted to bring this issue because, you know, we've been talking about this for ages, and it's clearly that we need to invite the browser people to this talk, and we can't think of it inside just the DNS without outreaching there. And let's make a resolution to make it happen in 2019.
Yeah, and I applaud that you start the discussion, and I'm just throwing in the arguments already. Thanks.
Ray Bellis, I see. So there was a very useful side meeting at the last IETF between browser vendors, primarily HTTP folks and DNS folks. It really was very useful. We did hear from them at the time that there are particular attributes of the SRV record they don't like. The port number field in an SRV record is apparently incompatible with the browser security model, because they don't want the ability to override the port. It's an important part of what defines a site as being a site for cross-site security issues. To my mind, the simplest solution is a new resource record with optional additional processing that says to a recursive resolver, if this exists, please also look up the target, so that in the same way as we currently do for some other records, to avoid the latency issues. I've tried to engage with the HTTP folks on the mailing list that's created as a result of that meeting. Unfortunately, they're not really engaging back yet, which is a shame, but we can but try.
Yeah, we need to keep pushing this on.
Okay. Evan Hunt, IOC, co-author of the ANAME draft, which has an explicit design goal of eliminating the vendor lock-in that you mentioned earlier. I like this. I think this is good. I hope it I hope it progresses for the use cases that you identified other than CDN, diacritics and things like that, where you have two domains that are intended to be identical. I think this works very well. And I agree with you that SRV is the best possible solution for browsers, but they're not going to do it. They're just not. We've been asking them for a very, very long time, and they've been digging in their heels and saying no. I'm somewhat skeptical that they're even going to do the alternate RR type that Ray mentioned, although I hope that they will. Essentially, the reason that I wrote the A-name draft in the first place was coming to the conclusion that we just have to be the bigger people and do the dumb thing that they're insisting we do. It's like feeding a toddler. If you want them to eat, you're going to have to give them the food that they will eat.
Tony Finch, University of Cambridge. I've recently started helping out Evan with a massively revised version of the A-name draft, which we're hoping to get submitted to as an inset draft before the cut-off for the IETF meeting in a week's time. So if you have read the existing A-name draft and you don't like it, please read the replacement draft, which is very different. One of the things that we're trying to do is much more emphasize data portability. My DNS setup at work is not CDN-like at all, and one of the biggest problems I have is dealing with people who want to provision websites. Sometimes they give me IP addresses, sometimes they want a CNAME. If I can just say yes to them and put it in an A-name record or put in some address records and they go away happy, that makes my job a lot easier. So I'm thinking of it much more from the point of view of making provisioning records that conflict with zone apexes or conflict with MX records much simpler for the web guys who find it hard. So I encourage you to send feedback on the revised draft.
Hi, Tail. I wanted to start off by saying that I was really impressed when you came up with the CNAME plus DNAME hack. It's kind of beautiful in its own way. I don't know that it's going to get any real traction, but I wouldn't be completely opposed to seeing it get traction. And I wanted to emphasize what Evan said. The SRV is a complete non-starter, and latency is one of the biggest issues for them. But there are, as you know, as Ray mentioned, several other issues that come up with their security model and so on. But the one way that I see that it could possibly be a starter, which I'm surprised didn't get mentioned, is a different proposal that Ray had come up with, and we've also come up with in a few different ways of looking at the same problem, and in particular Ray's draft for multiple queue types, but Warren and Wes have also worked on a draft for multiple responses. We've done this comparison of like there are 4 or 5 different ways of kind of looking at the same elephant and deciding what part you're looking at. I still stand behind the multiple queue types because that's one way of addressing A, quad A, SRV all in one go without having to worry about the issues that Happy Eyeballs has, for example, with racing queries and then maybe not getting some query back that they should have gotten back. You know, that you can still encapsulate it in one message. I'm really in favor of that, and I still hope that that moves forward. So.
Benno Overeinder, DNS OARC Working Group co-chair. Thank you for this discussion. It's important, indeed, we need to solve it. It also has the attention of the co-chairs. I do hear different solutions, so we need, indeed, as you stated, progress. And yeah, we're talking already a long time. SRV records for the web and
yeah, but
a lot of pushback here.
I know, but I think it was important to bring it also to this audience.
Yeah, especially I would like to, because now we see the same people. I'm so happy OARC is giving us time. The PC is giving the DNS OARC working group time here to discuss. But because I do see the same people in the ITF and here. So we need to have the other people also in this discussion to go forward. And for the A-name and the vendor lock-in, well, yeah, I hope if there are standards and there are more implementations, we can get around that.
Hopefully,
yeah.
Hopefully. But this is also the venue that has registries, because some of the solution might need cooperation from registries. we have more operators here. I don't know, maybe there are even some CDN folks here. So we really need a focused attention to this problem, and we need to solve it. Otherwise, we will get more into the vendor lock-in, and we, as a DNS community, should not want it.
Yeah. Thank you.
Okay. Thank you very much.
So next up we have 3 lightning talks, and the first one will be from Tony Finch.
Okay, I'm Tony Finch. I work at the University of Cambridge. This is a follow-up to Sarah's comment about encouraging people to deploy DOH and DOT. I deployed it on my central recursive resolvers last month using my own implementation based on Nginx and Lua, remarkably similar to Cloudflare's. It's running as a proxy in front of bind on the same IP addresses that we advertise via DHCP. We have a big wireless network on EduRoam, which when I did some statistics last week on Wednesday, we had between about 29,000 and 31,000 devices associated on our wireless network. The total queries per second on our recursive servers are about 39,000. As you can see, not very many people are using DNS over TLS at the moment, but it's a non-negligible number. So when you turn it on, you will get users immediately. So I encourage you, if you are thinking of turning it on, run a PCAP to find out what kind of level of traffic you might expect from your users. As you can see, I'm getting less than about 1% of our user base are using Android P and therefore hitting my DNS over TLS service. Android is very good at using persistent connections in following the TLS keep alive EDNS option. So I've set it to 5 seconds to keep the number of concurrent clients small. But there's a very long variance in the length of the connection. So if somebody hits a web page with lots of ads, they will remain connected for like 30 seconds, but most connections are really short. And the average number of queries per connection is surprisingly low. So that's all I have to say. Any questions? No, good.
So you mentioned Android as a client. Are you seeing any other clients?
Only from people that have explicitly configured things. So an office mate has configured Unbound as a client using DNS over TLS. But it's the number of people who have actually manually configured it is like me, my office mate, maybe 1 or 2 other people.
So Bert Hubert, Power DNS. We really care about offering DNS over TLS to like everyone and everyone and everyone. We do see that there could be modes where phones from popular vendors could end up having an open TCP connection to our name servers 24/7, which means that a 20 million customer service provider might end up having 20 million simultaneous active TCP sessions. Which may be where we end up, and if so, we need to plan for it. My call is really for everyone that is planning to do DNS over TLS service to please talk to us, because there are considerations on the large-scale resolver side things, and there are considerations on the battery use side and network efficiency and stuff, and we need to hopefully find some interim period where we get best performance for everyone. And sorry, Sarah, I think I skipped in line before you, but sorry for that.
But I chose 5 seconds based on sort of eyeballing how long queries lasted within an open connection, how quickly the queries tailed off. And 5 seconds seemed like a sort of happy medium based on just casual eyeballing. Yeah. And so I kind of reckon that based on a number of queries per second. The numbers are too small to be really firm, but we've got like fewer than 100 people using it, but the number of connections is much smaller than the probable population of.
It is real early days, but I could envision phones having several parallel sessions to get better latencies. And
Well, they don't need to do that because it's out of order.
Yeah, well, let's talk. Let's talk.
Sarah Dickinson Synodon, a very similar topic actually. I'm talking next week at RIPE about how we're going to start doing benchmarking of DOT and DO connections. So this is an appeal to yourself and to other people who are deploying it. Could you think about privacy-preserving ways of collecting data about how these clients behave so that we can learn how to optimize the number of connections, the idle timeouts, and understand client behavior? Because we do see different client populations because of different client parameters. So please consider that.
Thanks. Next up is Brian Dixon.
Hi. So I had this idea, came to me doesn't matter how I thought of it, but the idea is sending UDP responses based on the originating MAC address coming in on your network connection. And it's just looking at what things are like when you don't do that, and then what happens when you do that, and what the benefits of it are. I had some private conversations with folks about this, and I didn't have any negative feedback. I had quite a bit of positive, so that's why I'm talking about it today. So if you don't, the way things normally work today is you typically route your responses back when you're running a DNS Anycast instance, which means that if you get spoofed source packets, like a DDoS attack, those will be mingled with legitimate packets that you're sending back to the IP address that is in the source address of the UDP packet. This means that if there is a DDoS attack, the authority operator has to be involved in resolving that issue. And there's not much pressure on the ISPs that don't block spoof packets to fix their networks. And there's collateral damage to the other name servers or other clients that are behind an ISP that doesn't behave badly. If you change things to use the MAC address of your network connection to your BGP neighbor at wherever you're peering with them, you're sending them the responses back to the original incoming network regardless of what the IP layer stuff in the packet was. So you're blindly ignoring what the IP address is, which is okay if it's not spoofed, and if it is spoofed, it actually has some beneficial effects. If you have a lot of different peers, what the heck? Oh, sorry. If you have a lot of neighbors at some exchange point, this creates a significant improvement. How is this? Oh, okay, sorry. That you can then, with the peers who aren't spoofing, you get the ability to guarantee that their response traffic is going to be only legitimate responses. And the attack traffic will be sent back to the peer that was sending it in the first place, that leaked those spoofed source packets. And then the amplified traffic goes back to them and then over to their network peer, which creates the back pressure from the victim ISP to the bad player ISP that's allowing the spoofed sources and cuts the DNS provider out of the picture. Sorry, it's hard to, the picture tells a better picture than the words do. But here's what it is before, where the spoof packets are being sent to the Anycast. They get amplified and sent to a neighbor. That attack traffic is potentially causing damage to legitimate traffic and can't be distinguished. If you send things back based on MAC address, you can now distinguish the traffic that is coming in from the legitimate peer, you don't have to do anything special. It just automatically works. You send it back to the MAC address. If it came from the real non-spoofed transit provider, it gets returned with no problems, and it avoids any collateral damage. And the only victim as far as collateral damage is the guy who's actually allowing the spoof source packets to get through. So it's potentially a little bit controversial, but I think if you've got a peering agreement with somebody that says, you're not going to send me spoof packets, then taking this kind of action, I think, is completely legitimate. Anyway.
Thank you, Brian. Ray Ellis, I see. I like this a lot. As it happens, despite Bert's best advice, I've recently written it's like a fast root server that just uses raw sockets. And because I'm using raw sockets, I'm not looking in the fib to see whether to return the packet to. I just reverse the source and destination MACs or in the original packet. So it by default works this way. So the added side effect of deflecting back DOS attacks back to the sender is fantastic. And one I hadn't thought of. Thank you.
Yeah. Oh, and I would add the benefit of doing this increases the more operators do this. The aggregate effect. Everybody has to talk to us to get their DNS packets. So if we all do this, it could potentially make a much better internet where there aren't any spoofed packet attacks that are using DNS for amplification.
Ralph Weber, I have a question. So what will happen if my routing table tells me something different than sort of the MAC address? I mean, in the case of asymmetric routing.
Asymmetric routing, it's a corner case. I don't think it's necessarily going to be bad. In fact, symmetric is probably going to be more reliable in terms of debugging what's going on. So it's
Well, I mean,
yeah.
Again, one of the things of routing is, especially when you talk between ASs, is more about cost than about actually.
Yeah, I understand that, but if somebody's sending packets to a particular upstream and then trying to get traffic down through a different downstream, they're already kind of playing games, and as long as their upstreams honor that, the fact that it goes to one ISP first, it can still get to the right place and mostly work. I think you can potentially look at enabling that once your neighbors have proven that they're BCP 38 compliant. I would say start without allowing that, and then if they are good players, then allow them to do the routed versus the MAC address.
Hey, Dave Knight, New Star. Perhaps I'm missing something. I'm a bit slow this afternoon. Where do you implement this? Are you implementing this in the router or in the authority server?
We're not quite at the point of implementing it, but for the most part, it'd be just passing the packets along with the layer 2 headers still attached. So it's very much like the layer 2 fast return that you have on load balancers or something like that, or doing things with like different VLANs and keeping the original source MAC address and then doing a straight layer 2 response. Okay. It requires a little bit of hackery to make work in some cases, or you've got a 1U box that's router as well as your DNS server.
Right, that was it. They're trying to see past this corner case where you have the authority server in the same broadcast domain as the peers.
Yeah.
I'm not wrapping my head around how, on return, you actually direct things on the other side of your border router to a specific.
Yeah. So in some cases, it might be you implement it using a specific VLAN per BGP neighbor, and you hard code the rewriting of the IP or the MAC address on that particular VLAN. Yeah. It's not necessarily an easy way to do it, but it's not that difficult.
Yeah. Giovanni Saidian, interesting idea. I just feel a little nervous because you're making decisions on application layer and implementing on layer 2. So I'm not sure how we're going to pan out that in the future if it gets deployed. What people on transport layer are going to think about it, or routing layer. I feel I'm not sure how it's going to pan out in the wild, and I'll be a little scared of deploying that because, yeah, I'm just not so sure. But it's an interesting idea, I get it.
Yeah.
And DDoSes nowadays, there's another thing. I mean, a lot of people are doing DDoSes with legitimate packets. You don't need to spoof anymore because you have this super huge IoT botnet. So, you know.
Yes. So, I mean, I understand that it doesn't fix all the problems, but it fixes one of them.
Yeah, it does.
Yeah.
But does it create more problems?
Last speaker will be Peter van Dijk.
Hello again. It looks like, again, I have 1 minute. So I'd like to talk to you about the use of TTLs in NSEC aggressive use. Imagine this NX domain reply. For how long will the NX domain status be cached? Please shout. 900 seconds. For how long will the NSEC be cached? It's 1 day. For how long will the aggressive NSEC will be applied? It's 1 day. Except this is .com, it's using opt-out, so there's no aggressive use. But this is to demonstrate the general principle. NSEC aggressive caching takes the TTL of the NSEC, which is not the same as the TTL of the negative response, like the NX domain. This situation we can fix in the aggressive NSEC RFC. It's an oversight by the authors. Warren has basically admitted this to me. However, for the similar wildcard situation, there is no SOA we can gather the lower TTL from. So to fix this, we need to either fix RFC 4034, which will have a very long deployment tail problem, or we give operators the operational guidance to make the SOA TTL and the SOA minimum the same. It's my proposal that we write down the latter, that we give an operational guidance so that anybody that cares can fix it in deployment. Any questions?
Jeff Houston. Will this count as part of the 2 pages per week of the RFCs of the DNS?
OARC does not publish RFCs, but it can publish operational guidance. Thank you.
So before we all start the lunch break, Keith will have some announcements. Lunch break, coffee break, sorry. 1 lunch is enough.
Okay, my day's been like. Okay, a few quick announcements. So this ends the public workshop. I think now is an appropriate time to thank both all of our speakers, the program committee for putting everything together, and our fine team of volunteers and helpers with doing things like the webcast and everything else. If you could all show your appreciation, please. Again, one final thank you to our sponsors, VeriSign as our premium patron for our 2 workshops this year, RIPE NCC for the excellent connectivity as our deluxe sponsor for this event, our associate sponsors for this event, Comcast, Detect, and Power DNS, and our contributor sponsors for this event, SIDN and VeriSign. That takes me on to the survey. As I say, SIDN have kindly providing a $200 gift voucher for a raffle on the survey responses, or drawing on the survey responses. The survey will be open until the end of Tuesday. So we'd really appreciate your feedback, both on the content, so that we can compare that to the program committee's scoring and make sure we keep the quality of the content up. And also on the the logistics of the meeting as well. And there's also some useful data gathering we have in there about co-locating meetings and cost of accommodation and such like. Okay, that moves me on to the AGM. If you are the voter registration for your organization, or you think you may be, please go and see Sue. Also, please start doing that at the start of the coffee break. Please don't leave it to a last-minute scramble at the end, because otherwise that will delay the start of the AGM, and then you won't get away to do beer at the end. If you're a member representative but you're not the voting representative, then you are welcome to stay to be present for the AGM. Likewise, if you're a supporter organization but not a member, you're welcome to attend the AGM as an observer but not with voting rights. Because we need to make sure that we have only members in the AGM, we need to vacate the room. So if everyone could please leave the room. It's okay to leave your stuff now. Also, RIPE registration has started, so if you're not going to go and do your RIPE registration immediately, please can you stick to the coffee area on this side of the room and leave space for the right people to get their registration stuff done. For the non-members amongst you, our next workshop will be in May in Bangkok, so we hope to see you then. I'm sorry? Yes, please, yeah. Also, this ends the webcast. We will not be webcasting the AGM.
Hi, just a request, if there's someone from Microsoft here, I would like to talk to them. Please find me.